Hi, I'm Karen, and I'm going to explain the assignment 1. So for design task 2, we are required to design 2 subsystems. Subsystem 1 will calculate the weighted average, while subsystem 2 will calculate the difference ratio. So both systems requires 2 input from the sensor, input 1 and input 2. So for the weighted average, it is actually calculated based on the equation. The input 1 multiplied by its weighting factor plus input 2 multiplied by its weighting factor divided by sum of weighting factor, which is 1 based on the requirement. So to simplify, the equation will be this. 0.7 is the weighting factor for input 1, while 0.3 is the weighting factor for input 2, which is set in the system. So sensor 1 will have a higher weighting factor, which means that this system prioritizes sensor 1 more than sensor 2. So the calculated weighted average will be displayed here. And for subsystem 2, the difference ratio is calculated based on the equation given. So similarly, after calculating, this difference ratio will be displayed here. So for example, this is the calculated weighted average and the difference ratio. And the difference ratio is can be used to detect any fault condition or mismatch condition. For example, if 2 sensors are the same sensor, so they might have similar or the same reading. So you will get a difference ratio very close or equals to 0. That's all for design task 2. For design task 3, we are required to build a circuit which receives 3 inputs, A, B, and C. If 2 or more inputs are high, then the output should be also high. In this case, 1 will be represent high, while 0 will be represent low. So after completing the truth table and the K-maps, this is the expression for the circuit, and this is the original circuit built from the expression obtained. And for optimization, this circuit will convert to NOR gate implementation, which is shown at here. So if no inputs are high, then I will get a 0. If 2 or more inputs are high, then I will get a 1 here. Similarly, I will get a 1. So if only 1 input is high, then I will get 0. So that's all for design task 3. Design task 4 required us to design an elevator control system. So this system requires 3 inputs. If door is equals to 1, means the door is open. If door is equals to 0, means the door is closed. And this is the current flow number and the requested flow number. So this system will produce the output, which is the motor operation, represented here, the second bit and the first bit. So 0, 0 means stop, 0, 1 means move up, 1, 0 means move down, and 1, 1 is stop. So based on these 3 inputs and if action system, we'll make the decision for the motor operation. So the first statement, if the door is greater than 0, means if the door is open, or the current flow is equals to the requested flow, the motor will stop 0, 0. So for example, if the door is open, it will get 0, 0. And if the floor number is the same, even if the door is closed, I will get 0, 0. And for the else if statement, if requested floor is greater than the current floor, means the motor has to move out. So I will get 0, 1, move out. And the else statement, which means that the current floor is greater than the requested floor, means the motor will have to move down. So I will get 1, 0, which means the motor will move down. So the if action subsystem will produce two outputs, which is the second bit and the first bit of the motor operation. So by using the merge block, the two outputs of this if action subsystem will be combined and displayed at here. So that's all for design task 4. Thank you.